Just like multiplying and dividing, the rules for adding rational expressions are the same as the rules for adding fractions. So if you have a common denominator, you just add the numerators. And if you have a uncommon denominator, then we'll look at that in a little bit because we have to do a little more math to get the common denominator. So the denominator stays the same and you add the numerators. So in letter A, 2x, and then 5 plus 7 is 12. You want to make sure that you reduce if you can. So this reduces to 6 over x. Okay, I'm going to write out letter B with a little more work than I did in letter A. When you subtract, the denominator stays the same, and you subtract the numerators. But when you're subtracting, I want you to write it out first, at least for a while, because you have to remember to distribute this negative sign to all the terms. If you don't write the negative sign, if you don't write the parentheses, you'll just think that the negative only goes with the y, but it also goes with the 8. So now when you distribute, you get 3y minus y plus 8 over y plus 4. So that gives me 2y plus 8 over y plus 4. And I have to factor, so I'll get 2 times y plus 4 over y plus 4. Those cancel, and I just have 2. So would you believe, looking at this question, that the answer is 2? I wouldn't, but it is. When you have unlike denominators, I mentioned earlier, you have to do a little bit of work to get the common denominator. So let's forget about the numerators, and let's just look at the denominators. I've got 10g squared and 12g. So remember a long time ago, I told you that the GCF is the smallest exponent, or the smallest number of exponents. I think that was chapter 7. Well, the LCM, or the LCD, is actually the largest number of exponents. So we're going to use this idea to help us with the common denominator. So the common denominator of 10 and 12 is 60. And the common denominator, or the common multiple, for g squared and g is g squared. So the least common denominator is 60 g squared. So that's how you find a common denominator. You find the common multiple of the coefficients, and you find the common multiple of the x of the variables, which in this case is the largest exponent. So let's see how that works. So first I need to get a common denominator. The common denominator for 8 and 6 is 24. And for the variables, it's going to be x squared. Oh, I didn't give myself a lot of room. So I need to figure out what I have to multiply each of these by to get 24x squared. So I have to multiply this one by, well, let's see. That's going to be 3x. And then this one is going to have to multiply by 4. Because you need to figure out what you need to multiply by to get 24x squared. So here we go. Well, 3x times 1, that was easy. That's just 3x. 4 times x minus 2 is 4x minus 8. So now I have to add those. Denominator stays the same, and I'll get 7x minus 8. This is not factorable, and neither is, and this, well, it's a monomial, so you can't really factor it. So that's the best we can do. All right, let's check out one with a trinomial. Ooh. Okay, so first I'm going to factor the trinomial, And again, I told you that this is probably a hint. This is probably telling us that x minus 6 is inside of that trinomial. So I'll use that as a clue, and I'll just see if I can figure out what the other one is. That's going to be minus 2. So I have to figure out what I need to multiply each of them by to get a common denominator. Well, conveniently, the only thing I need to change is the second fraction, because this first fraction has x minus 6 in it. So the only thing I need to do is multiply this by x minus 2. And then I have a common denominator of x minus 6, x minus 2. So the first one stays, x plus 3, because I didn't have to change that at all. And the second fraction turns into 2x minus 4. So denominator stays the same, x minus 6, x minus 2. And let's do it. X plus 3 minus 2x minus 4. And again, I use parentheses to remind myself that I need to distribute. So when I do that, I get x plus 3 minus 2x plus 4 all over x minus 6 times x minus 2. All right, keep going. When you combine your terms in the numerator, you get negative x plus 7 over x minus 6 times x minus 2. And neither of them have anything that I can divide out, so that's what we got. If you wanted to, I guess you could go through and multiply these back, but there's no reason to, so why do the extra work? All right, last one together. Pause the video, read it, and then I'll walk you through that setup. So this tells me that the distance divided by the speed gives me the time. And that comes from a formula that you may or may not have ever heard of, which is D equals RT, distance equals rate times time. So you can figure out a distance if you know the rate and if you know how long it took you. So let's use those two ideas. Well, the distance downstream is 5, divided by the speed downstream is x plus 1. So this whole expression right here is the fraction 5 divided by x plus 1. Distance divided by speed gives me time. Plus the distance upstream, well, if it's down 5, then it's also up 5. And the speed upstream was x minus 1. So I have to get a common denominator. They don't really have anything in common, so I have to multiply this by x minus 1 because that's what the other one had. And this is going to multiply by x plus 1 because that's what the other one had. So this becomes 5x minus 5 over x plus 1 times x minus 1 plus 5x plus 5 over x minus 1, x plus 1. It doesn't matter whether you write plus 1 first or minus 1 first. So now let's combine. I get 10x, and then the minus 5 cancels with the plus 5. X minus 1, x plus 1. I can't simplify anything, so that's it. That's the expression, and if you have any questions, write them down and ask me when you come to class.